All right, so again, we are working with the problem if we had the number 9 instead of 15. So I will show you guys how we would go about this and how you will write it in interval notation. So first, we're going to set our 3x minus 9 to be greater than or equal to 0. You're going to add 9 to both sides. So now your x is going to have to be greater than or equal to 3, and your x also cannot be 4. So it's a little bit awkward, I think, to do this one in interval notation, which is why I kind of wanted to show you guys how to do a problem like this. So what you're working with is when you want your x to be greater than or equal to 3, again, we're going to start with a bracket. And you need to include that bracket there because you want to make sure that you're showing that your x is going to be equal to or greater than 3. And now it's going to stop at 4. Union. Just to show that even though its x is greater than or equal to 3, it still cannot be equal to 4. So that's why you're including that 4 in there. And then you're using a parenthesis to show that 4 is not included. So that's how you would write out a problem like this, and this is how you do a problem if we're talking about like the domain rule where you have a square root on the top and then a fraction on the bottom, and you're taking the intersection of these. Section of being greater than or equal to 0